Welcome to another set of video notes. Today we're moving on to 3.3. We're going to look at how to solve systems of linear inequalities. Now hopefully some of those words sound familiar. We looked at inequalities last chapter. And what are some things we have to worry about inequalities? Oh yeah, if it's less than or a greater than sign, we're going to have a dotted line. Do you remember when you make it a solid line? Yes, when it's less than or equal to or greater than or equal, that becomes a solid line. And then don't forget, what's the other big thing we had to do? Yeah, we had to pick a test point and shade. Okay, so that's kind of just a little review for you to remember about graphing linear inequalities. Now, because we call them a system, there's going to be two inequalities. Okay? Now, the one thing I want to share with you is what I'm expecting you to be able to do after this lesson and what the book's expecting are a little different. When you wind up doing some exercises for me, we're going to have a whole bunch of different things that you're going to do. You're going to do some matching. It's not quite as intimidating as it seems for the book. But in the spirit of let's get the hard stuff out of the way, that's what we're going to do first, okay? So right here I have your steps that you probably would use on your study card. How are we going to graph inequalities? Well, you graph your first line. And we've worked a lot about how to graph lines. You have to get y alone, and we've worked on that. Don't forget, because it's an inequality, we're going to decide whether it's a solid line or dotted line, and then we're going to shade. Because it's a system of inequalities, we're going to have to graph the next line. Okay? We're going to do the same thing. Get y alone, decide solid or dotted, and then shade. And then the third step, we're going to look for the area that we shaded twice. Now, I know this isn't your favorite, but it really is the best way to show you. So we're going to go to the smartboard. We're going to look at some examples. So be prepared for us to move a little, and we're going to have our lights turned off in the back so that you get a better idea. Okay? So here we go. Your first inequality, y. Oh, can we turn off all the lights? Awesome. Here's our first inequality. Y is greater than negative 2x minus 5. Now, the y is already all by itself. Let's think about these two numbers. Where are we going to start? Oh yes, we're going to go down to negative 5. That's your y-intercept. And then you're going to go down 2 and over 1. Okay, so that doesn't seem too bad. Then we'll have a second inequality. Oh, I forgot to say, is this going to be solid or dotted line? Dotted. And we're going to test our point and see. Okay? This one, y is by itself again. Yay! Makes it easy. We've got 1 and we've got 3. Which number do we start with? Well, this is the slope. 1 is the slope. And 3 is the y-intercept. So we'll go up to 3. We'll go up 1 and over 1 and draw a solid line. And then we'll be shading, which we'll look at in just a second. Okay? Now, if you notice, here's our solution. This one is negative 2x minus 5. And if we put 0 in, is 0 greater than negative 2 times 0 minus 5? Oh, yes, it is. 0 is greater than negative 5, so we shaded above. Now, when we go to do this line, it's at 3. You go up 1 and over 1, and we draw a nice solid line. If we check 0, we're going to say 0 plus 3, that's 3. Is 0 less than or equal to 3? It is. So we shade below. Now, this part and this part cross right in here, so that's your solution. Okay? Let's look a little more at another one. Now this one's going to be a little bit trickier because it hasn't gotten y all by itself. So let's think about what we have to do. And in fact, let's go ahead and turn on the lights so that we can see what we have to do. Okay? Ignore this. In fact, we'll come over here. Okay? Sorry to make you move so much. Hope none of you are motion sickness. It's going to be a rough time. So if you have 2x plus 3y, and that is less than 6, we subtract our 2x. We now have 3y less than negative 2x plus 6. What else do we need to do? Divide by y, or the number that's with y, excuse me, so that's divided by y. Now, are we going to have to flip this around? No, it's fine. We've got negative 2/3 x, and what's 6 divided by 3? Well, it's 2. So let's kind of think about this. This means, what's our y-intercept? 2. It tells us to go down 2 and over 3. So there's our 2 points. Dotted or solid line? Dotted. And then we try the point 0, 0. Well, I put 0 in here. Oops, that's not good. I put 0 in here. What is 0 plus 2? Oh, it's 2. Is 0 less than 2? Yeah. So we should be shading below. Okay? Let me just go ahead and tell you what the other inequality is going to be. This time I'm going to be nice to you. See, I'm not so bad. Negative 2/3 x plus 4. Wow, that kind of looks a lot alike, doesn't it? So, let's see. If we graph this, we go up to our y-intercept of 4. This tells us to go down 2 and over 3. Solid or dotted this time? Oh, solid this time. Okay, now, let's try the point 0, 0. I think we have a problem here. Nope, okay. So let's try 0, 0. And we've got 0 is less than negative 2/3 x plus 4. Put 0 in, and you've got 0 is less than or equal to 4. Do I have all this written correctly? I think so. Okay, so the things that are below is what we're going to shade. Okay, so now let's go back to the dark and look at it. Okay, so go back to the smartboard and we'll turn off the lights. There we go. I have several people helping me today. So, oh, they made a typo. That's why this is not working out. Notice they changed it to greater than. So if we had greater than, it would be above and below, and there's nothing in common, so there's no solution, and that can sometimes happen. Okay, let's look at, I don't think I want to do that one. Let's look at this one. I just want to give you some more examples, okay? So, 3x minus 2, how would you graph that? You'd go up 2, or down to negative 2, up 3 and over 1. Solid or dotted? Solid line. And if we try putting 0 in, 0 is less than negative 2. That's not true, so we don't want to cover up that point. We want the other side of the line. Okay? When we come to this one, we go up to 4. The slope is negative 1, so down 1 and over 1. And we make a dotted line. If we put zeros in here, is 0 greater than 0 plus 4? Let's see, is 0 greater than 4? No, so we don't want this point. We want the stuff above the line. So to the right and above is going to be this section. Okay, now the one thing that you're going to wind up doing a lot is you're going to match the graphs. Like I'm going to give you the finished graph and I'm going to give you the inequality and I want you to match them up, which makes it a little bit easier. You just have to be able to look at the graph and go, oh yeah, this has a y-intercept here and a slope of negative 3. It should be solid, it should be dotted. You'll be checking things like that, okay? Let's go ahead then. I don't think I really have any more that I necessarily want to look at on this. Instead, let's look at another kind of example I can ask you to do. So we're going to go ahead and swing around to the other board and turn on the lights. Okay, so the other thing I'm going to ask you to do besides matching graphs is determining if the ordered pair is a solution. So one thing is to look at the graph. If the point is shaded, then it is. So that's pretty easy. The other thing is I might give you a point like, what am I going to give you? I'm going to give you the point 3, 4. And I'm going to see if it's a solution to this system. So 2 times 3 plus 3 times 4, is that less than 6? Well, 6 plus 12, is that less than 6? No. So if it's not for 1, you know it can't be a solution to the system. Now if you notice, I don't think this would have been a solution for either one. Sometimes it'll be one and not the other. It has to be a solution for both. It has to be a solution for both inequalities for it to be a solution for the system. Okay? So that kind of takes care of all the stuff that we're going to do. We will be practicing this in class, although not with the same types of problems you'd see in your textbook. Okay? So have a good rest of your day, and I'll see you in class.